Initial value problem from differential equation. Previously asked question from CSIR net. If x1 and x2 both are as functions of t, this is given as a solution of initial value problem. Differential equations are e to the power minus t dx1 by dt is equal to minus x1 plus x2. In a similar way, in dx2 by dt equation is given, initial conditions are given, and r is as a function of x1 and x2, x1 square plus x2 square square root. Conditions are based on r as t is approaching to something. We need to check which of the statements are true. This is part C question, so more than one option will be the answer. Writing initial value problem, the differential equation we are writing again to simplify in terms of dx1 by dt and dx2 by dt. So dx1 by dt is equals to e to the power t into minus x1 plus x2. This is equation number 1. Similarly, dx2 by dt, we can find it from the second differential equation, and this is equation number 2. Initial conditions are also given. We'll be using them as to find the constants involved. We need to find r as a function of t to solve these conditions. Writing r as x1 square plus x2 square under the root. Differentiating. For differentiating, we are squaring this. R square is equals to x1 square plus x2 square. Differentiating with respect to t, both sides. 2r dr by dt is equal to 2x1 dx1 by dt plus 2x2 dx2 by dt. And substituting the values of dx1 by dt and dx2 by dt using equations 1 and 2, which we previously discussed. 2 will be cancelled out throughout. R dr dt is equals to e to the power t common minus x1 square plus x1 x2 minus x1 x2 minus x2 square. Middle terms will cancel out. We are left with minus e to the power t x1 square plus x2 square, which is actually r square. Cancelling r, dr by dt is equals to minus e to the power t r. Dr by r is equals to minus e to the power t dt, integrating both sides. So this will be log r minus e to the power t plus log c. Log on one side, log r minus log c. We need to find r. This is our aim. So log r upon c is this. Shifting log, this will become exponential on the right hand side. So r is now c into e to the power minus e to the power t. This is our solution, r as in terms of t. Now we'll find the value of c using initial conditions. Initial conditions are given as x1 at 0 is 1 and x2 at 0 is 0. So substituting these values, when t is 0, x1 is 1 and x2 is 0, and r will be x1 square plus x2 square square root, it's 1. So substituting in 3, when t is 0, r is 1. By this we can calculate c. E to the power 0, 1. So c is actually e. We can replace c by e. Now r becomes, r is equals to e into e to the power minus e to the power t, and this can be written like this, e to the power 1 minus e to the power t. So now this is the solution after using initial condition. Now we need to check the options given. Now option A. Option A states r of t goes to 0 as t goes to plus infinity. Substituting t as plus infinity and finding out r. So this is e to the power 1 minus e to the power infinity. E to the power infinity is infinity. So e to the power minus infinity is 0. So first condition is true. A is correct. Now checking the second option, B. Second option says r at ln2 is equals to e to the power minus 1. Means when we substitute t as natural log of 2, we get the value of r as e to the power minus 1. Using the same equation which we have solved previously, put t is equals to ln2 in the equation. This will be r is equals to e to the power minus 1. So B is also correct. C cannot be correct because C is giving the different value as at ln2. R at ln2 is equals to 2 e to the power minus 1. This is not true when B is true. So checking D. D option says RT into e to the power t goes to 0 as t goes to infinity. So first find the product R into e to the power t. Multiply e to the power t with r. So now this will become e to the power t upon e to the power t minus 1. Now substituting t as plus infinity, taking t as plus infinity, this will be e to the power infinity upon e to the power infinity. So this is infinity by infinity form. We need to apply LH rule. This will be e to the power t. Derivative of denominator will be e to the power t minus 1 into e to the power t. So 1 e to the power t from denominator will cancelled out with the numerator, and we are left with 1 upon e to the power t minus 1, which is 1 upon infinity, and it's 0. So D is also correct. So 3 options are correct in this case. Option A, B and D. These 3 are correct. So this is final answer.